Exponential growth and decay are done the same way. Exponential decay, the formula, the only thing different in it is instead of 1 plus the rate, it's 1 minus the rate. So what that means is if in the parentheses, here and here, if it's greater than 1, it's a growth. Because some of our problems today, you'll be given a formula and you just got to identify whether it's a growth or a decay. If it's less than 1, it's a decay. Okay, so that's all you look for. Now this part right here is called the growth rate. So you can probably guess then what this is called?
The decay rate.
The decay rate.
So like it would be like a negative.
Not inside here, no.
Oh, never mind.
So like if it's 5%, 1 take away 5% is 0.05, right?
Yeah.
So it's 1 take away 0.05
So it'd be like
is 0.95. So if you're looking at the graphs, an exponential decay, exponential decay, I'll have to do it over here. An exponential growth will start low and then it'll rise up fast. And exponential decay comes down and gets smaller and smaller and smaller. Oh, it froze up again.
It's like
Okay, so when we did the exponential growth, we had investing money and you'd make money. Exponential decay deals with depreciation. Depreciation. So remember the formula is the initial amount times 1 minus the rate to the t. So if you got a car that you buy for $20,000 and you guys know this, the value of it goes down, right? That's called depreciation. It depreciates at a rate of 25% each year. Write an exponential decay model. So it's y equals the initial amount times 1 minus the rate. So remember, 25% is 0.25. So 1 take away 0.25 is 0.75. And they just want the model. So then it doesn't say how many years it is, so you just put t right there. So if they did ask, how much is the car worth after 5 years? All you'd have to do is put 5 in right there. And we figure them out the same way. 20,000 times 0.75 raised to the 5th. It would be worth $4,746.09. Okay? So instead of the answer getting bigger, it's going to get smaller because this number is less than 1. Make sense to everyone?
Mm-hmm.
Okay. So here we've got a boat. The boat costs $3,200. And it depreciates at 13% each year. So write the model, it would be y equals 3,200 times 1 take away 13% is 0.87 raised to the t. And then when they say to figure out the value after a certain amount of years, here it's asking for 3 years, you just punch that in. And it gives you its value, $2,107.2096, which remember again, this is money, so it'd round to 21 cents. Now they've given us easy percentages. When they give you, these are easy to do in your head. It's just 100 minus 13 is 87. Now if it's something like this, 4.8%. That one you may need to use a calculator to figure out. Because you move it 2 spots, it's 0.048. So one takeaway, 0.048, is 0.952 raised to the t. Okay? So it's not as easy to do in your head when it's an odd percent like that. But it's not so hard. Okay, the graphs we don't have to do, so that's all we are doing now. If you had some equations like this, okay, identifying if a problem is an exponential growth or an exponential decay. You remember what you gotta look at? So this is greater than 1, so it's a growth. This is less than 1, so it's a decay. This is less than 1, so it's a decay. Then they ask for the growth factor or the decay factor. The growth factor is how much more it is than 1, which is 0.03, but you gotta write it as a percent, so that is 3%. These are a little harder to figure out. So what you gotta do is figure out,
Just take 1.
take 1 minus that, and it was 0.048, that's the one I had before, so that's 4.8%. And again, if you can't do it in your head, you take 1 minus that, you'd get 0.12, which is 12%.